we're back, and now we want to talk about static equilibrium. But before I do that, we were talking about how to add arrows together, and I was adding forces together. But remember that you could also add distances, you could add velocities together, and accelerations. So any kind of a vector, we would add them together using the same technique. All right, now back to what we were talking about. Static equilibrium. So if an object is in equilibrium, it is not going to be accelerating. So that means A is going to be equal to 0. And so Newton's second law, which is that force is equal to ma. So if A is equal to 0, then 0 times anything is going to be 0. So Newton's second law becomes the total force acting on a system is equal to 0. That's when it's in equilibrium. Now, does that mean that it's sitting still? Not necessarily, because if A is equal to 0, what does that mean? It just means that your initial velocity is the same as your final velocity. It just means your velocity is constant. It doesn't necessarily mean that velocity is equal to 0. Okay? So if your acceleration is 0, it doesn't mean your velocity is 0. It could be 0, but it just means that the velocity is constant. So that you could have a situation in which an object is moving sideways at a constant speed, and it would be in equilibrium. Okay? So let's take a look at an example of this. So here we've got a painter, and he's standing on top of a board, and the board is being supported by 2 wires. So you've got this board like this, then you've got the person standing on top of it, and then you notice over here there is a wire, and then the wire is attached to a spring scale, and then over here is the same thing. So this wire is attached to a spring scale so that you can tell how much force is holding up this side by looking at the number on this, and then you can tell how much force is holding up this one over here. But you also notice that he has a certain weight. So he's pulling down as these wires are pulling up. And then also notice that the board has a certain weight. It's pulling down. And then also notice that he has a paint bucket next to him, and then that also is pulling down. So the question is, a 600 Newton painter, so 600 Newtons, so that's him, okay, has a 100 Newton bucket, so that's that, and stands on a board of unknown weight. So we don't know how much does the board weigh. They are held up by 2 ropes with tensions of 700 newtons, and the other one is 500 newtons. Okay, so those are the readouts on it. Now, what we have to figure out is what's the weight of the board. So we're going to use this principle. The sum of the forces has to equal 0. So what are all the forces acting on the system? And remember, up is positive and down is negative. So we're going to have 700 plus 500 minus 600 minus 100, and then minus the force on the board, because the board is down, pulling down. That's going to equal 0. So we're going to solve that equation for the force on the board, and it turns out to be 500 newtons. So that's going to be the weight of the board itself. So this would be an example of how you would use equilibrium. Another example, which is more complicated, would be hanging a picture. So you've got a picture here, and then it's got like 2 strings that are attached to it like that, and you have to figure out if this thing has a certain weight that's pulling down. Can you figure out what would be the amount of force in this string and the amount of force in this string? Well, you would do that by adding the forces together geometrically, but we're not going to do that. So on the exam, if we do a equilibrium problem, all the forces are going to be parallel to each other, and we're not going to do stuff where it makes an angle like that. But it's not that much more difficult. It's just that we don't have time for it. Okay, got it? Good. So let's take a break. When we come back, we will discuss different types of forces.